Algebra 1, Section 10.5, Solving Quadratics Using the Completing the Square Method. Before I begin, I want to say this real quick. Hopefully you have a cadence going as to how you're completing Chapter 10, how you're completing the work for Algebra 1. And that cadence should be watch a video, do a homework assignment. 2 days later or whatever it is, watch a video, do a homework assignment. If you're already doing that, then this little disclaimer doesn't apply to you. I do fear that somebody might try to watch several videos and then do several homework assignments. That would be that's not a great thing to do, and that would be detrimental, I believe, in the case of 10.5 and 10.6. 10.5, you need to practice this before you move on to 10.6. Between the method that we're going to talk about today and the method that going forward into 10.6 and 10.7, they're at a higher level of solving. You know, your capacity to solve is going to be highly increased by these two. And I wouldn't want you to confuse them. So you need to really have a solid foundation in completing the square before you move on to the quadratic formula is basically what it is. Okay, so please do that. Let's look at this first example here. It says, well, before we get to the example, I actually have an example written out for you. And it says there on the left that we give you 45. And you probably remember these. They're called factor trees, where you divide out a prime number, 3 in this case, and then you're left with 15. And then what 15 divides into is another 2 prime factors, which is 3 and 5. And the prime factorization would be then 3 times 3 times 5. That's how you get to 45, is that it has those 3 prime factors. In Algebra 1, we're given something like 2x squared minus 7x plus 5. And that is also something that can be divided, as we learned in Chapter 9 with all the factoring stuff. It can be divided into 2 linear factors, those being 2x minus 5 and x minus 1. And if this were a Chapter 9 problem, I would have had you to put parentheses around them, and that's how you list it in factored form, right? This would be your answer, 2x minus 5 times x minus 1, okay? Now, moving on, we also have numbers like 49. And 49 can be divided into just 2 numbers that happen to be the same number, right? So 7 times 7 is 49. We deal with these in algebra as well. X squared plus 2x plus 1 is factorable. And if we factor that, you're going to get x plus 1 times x plus 1. Okay, so in this case, the 2 factors are actually identical. And you might have written that in Chapter 9 as x plus 1 in parentheses squared, or you can just write it as x plus 1 in parentheses times x plus 1 in parentheses. And that is called a perfect square trinomial. Maybe you remember that term from Chapter 9. The term really isn't that important, but that is what it is, okay? And then just to complete the thought, you know, you do have more complicated numbers, one being like the number 36, which it's a perfect square, just like 49 is, because you can divide it into 6 and 6. Then it can be divided further, because 6 is prime factors are 2 and 3. So really the prime factorization of 36 is 2 times 3 times 2 times 3. Or maybe you arrange those numbers differently, 2 times 2 times 3 times 3. But that's the prime factorization of 36. And then in algebra, although we don't do this to you, I just want to complete the thought, we could give you this quartic, something like this, which is a quartic function. And it itself can be divided into x squared plus x minus 6. Again, don't worry, we didn't do anything like that. We'll deal with more of that in your Algebra 2 classes and beyond. But notice that x squared plus x minus 6 is repeated over here. So this itself is a perfect square. I guess you'd call it a perfect square quartic. And x squared plus x minus 6 can be factored, hopefully you can do that one, into x minus 2 times x plus 3. And here it is again, x minus 2 times x plus 3. So you might say the prime factorization of this quartic expression is x minus 2 times x plus 3 times x minus 2 times x plus 3. Okay? And that again is like the equivalent to the 36, that it can be divided and divided again. Okay, where we're going to be living today is right here. We're going to be talking about perfect square trinomials. Okay, so look at the first example, and I want you to think about this. It says find the value of c that completes the square. Or let me ask the question this way. What value could you plug in for c that would cause you to be able to write it like this: x and x, factored form, and this number that goes right here is the same as this number that goes right here. I'll give you a minute to think if you want to pause the video right now to really think about that. This goes a long way to understanding what we're doing today. Okay, I'm about to reveal the answer, so if you want more time, please pause the video. And the answer is 64. C is 64, okay? And why would it be 64? Well, because negative 8 times negative 8 gives you 64, right? So that's the L in FOIL. And also the O and the I in FOIL would give you negative 8x minus 8x, which is negative 16x, okay? Now, if you were able to come up with that, great. If not, I'm going to give you the calculation for that anyway next. And whether you know this calculation or not, if you got that right, you probably did this calculation in your head. And the calculation is b over 2 squared. So that gives us this right here. For x squared plus bx plus c to be a perfect square trinomial, c, which is this value right here, is equal to b over 2 squared. Okay? So again, looking back at that example, negative 16 over 2 is negative 8. Squared is positive 64, right? So that's the answer. C is equal to 64 right there is their answer. So this is the calculation that you should know, and it should not be confused with negative b over 2a. I know they are kind of similar, but they're used for completely different reasons. In fact, I'll tell you this too. In a normal year, where you're here and such, after the Chapter 10 test, I leave this section 10.5 out, and we have a Chapter 10 test that covers all of Chapter 10 except for section 10.5. And then we do a day on completing the square, and then I do a little quiz on that, right? Because I don't want you to confuse those two calculations. And with the way we're assessing this here, you really shouldn't. But just be aware of that. Negative b over 2a is for finding vertices and axis of symmetry. This is b over 2 squared. Today's calculation that we're going to be using is b over 2 squared. Okay? And that first example will account for a few problems that are in your homework, I do believe. And then we're just going to do 3 others that actually uses solving. Okay, so here we go. Uses the completing the square method for solving, I should say. It says solve by completing the square. X squared minus 6x equals 247. Now, for all other methods, you would subtract 247 from both sides. That is not what you're going to do here. Okay, this is a different method. In fact, this one is already ready to go. And please notice that on the left side here, x squared minus 6x, you have somewhat like we had in that first example. We need to complete the square by adding something to this to force this into being a perfect square trinomial. And the calculation is b over 2 squared, in this case would be negative 6 over 2 squared. Follow your orders of operation. Negative 6 over 2 is negative 3. Squared means negative 3 times negative 3 would be positive 9. You are going to add 9 to both sides. Now caution, the most common place that I see a mistake is forgetting to add 9 to both sides. You're adding 9 to the left side to make this a perfect square trinomial. Whatever you do to the left side, you have to do to the right as well. So don't forget to add 9 to 247. And then you'll have x squared minus 6x plus 9 equals 256. Okay? Now, you might wonder, why would we do that? The reason you do that is because this is now a perfect square. You do not have to wonder as to whether it's a perfect square, meaning that it's something that can be factored into a linear binomial times itself. You don't have to wonder that. If you did b over 2 squared correctly, it is. It for sure is. And the next step then, it really should come clear, because this would factor into x minus 3 times x minus 3, or what we really should write is x minus 3 in parentheses squared. You really don't need this step right here. Okay? Now think about that. How would we solve this for x? Notice that your variable is being subtracted by 3 and then being squared. Well, why don't we go ahead and undo the squared and then undo the subtracting by 3, and we'll have our answer. How do we undo a squared? That's by square root. Also recall that in an earlier section, when you square root both sides of an equation, that's going to give you two solutions, two numbers on the right, if you will, a positive and a negative, plus or minus, and this would be 16. Square root of 256 is 16. And then finally, what you would do is add 3 to both sides. And here you have x is equal to 3 plus or minus 16. Again, this is probably an unnecessary step for both of you, but I just wanted to show you that what I'm doing is adding 3 to both sides, and it's going to yield 2 numbers. Positive 19, if you go 3 plus 16, it's positive 19. 3 minus 16 would be negative 13. X is equal to negative 13 and positive 19. And again, you can use the word or and or a comma, it really doesn't matter, but note that there are 2 solutions there. Now, I'd be remiss if I didn't at least bring this up. If you solved this by graphing, if you subtracted 247 from both sides and then graphed it, made a t-chart, graphed it, it would in fact cross the x-axis at negative 13 and positive 19. It would look something like this, where this number is, the x value is 19, this number, the x value would be negative 13. Okay. All right, now you might be wondering, because we're going to do 2 more examples, you might be wondering, because notice that the lead coefficient is 1 in every example we've done. Can this method be used for a values of something other than 1? Even in the only part that really I would consider notes, I didn't put an a here. I'm just assuming that's a 1. Yes, you absolutely can, but we don't deal with that in Algebra 1. This will come up in Algebra 2. Okay, I'm trying to give you the basics the first time around. All right, so here we go. We're going to do this 2 more times. Notice the constant is on the left side of the equation. This is actually the wrong side of the equation for using completing the square. The first thing we're going to do is subtract 3 from both sides. X squared plus 5x is equal to negative 3. Okay. Then I'm going to do b over 2 squared. I want to force this into being a perfect square trinomial. So 5 over 2 in parentheses squared. 2.5 squared is actually 6.25. X squared plus 5x plus 6.25, and it's equal to 3.25. Again, let me say, you added 6.25 to the left, you must add 6.25 to the right. You added 6.25 to the left to make it a perfect square trinomial. You add 6.25 to the right because that's what you have to do in math to keep something actually equal. Keep an equation, the left side and the right side, equal to each other. Okay? Now, this is factorable into x plus or minus something here times that quantity again, or what is more convenient to do is just use squared. And that something is 2.5. Now notice something, since we've done 2 of these. You know we've encountered this number already. It was in the calculation of b over 2 squared, right? So basically you do b over 2 squared to come up with this number, and then as you're factoring, it becomes b over 2. This number, it gets squared and then square rooted. This number, we've already encountered it. It's what's in the parentheses here. Anyway, let's finish the problem. Here we'll need a calculator. Notice it says round to the nearest hundredth on these last 2 problems. That's going to be standard, I believe, on all your homework problems. They'll say round to the nearest hundredth, so 2 decimal places. And when I square root the left side, I'll get x plus 2.5 by itself. And then I need to use my calculator to take the square root of 3.25, which is about 1.80. So plus or minus 1.80. Okay. And then I'll take that number on my calculator and subtract 2.5 from it. And I'll add 2.5 to it. And that's exactly 2.5. And it'll come out to these 2 answers. Negative 0.70 and negative 4.30. And by the way, that's not exact. You don't want to say negative 0.7 and negative 4.3 because the actual number on my calculator is 1.80 2775638, and I added exactly 2.5 to that. So those decimals still exist. They told us to round to the nearest hundred, so you should include the zeros, what I'm saying. And these would be your two answers. And I'm sorry to sound like a broken record, but again, if you graphed what we started with, the left side, it would cross the x-axis at these two numbers. Not as convenient as negative 13 and 19, but that's where it would cross that's where its two x-intercepts would be. All right, the last one I think is fairly similar. So if you want to stop the video now, I wouldn't be offended, but I am going to do one more. Some people want to see one more, I'm sure. Okay, so we're going to continue, and I would subtract 16 from both sides. And then I'm going to do b over 2 squared, negative 14 over 2 in parentheses squared is 49. Notice it's always a positive number too. Never negative, right? Because even if it's negative after we divide it by 2 and then square it, it becomes positive when you square it. So either way, this is a positive number. You're always adding 49 to both sides of this equation. X squared minus 14x plus 49 equals 33, right? And then we can factor this into x minus 7 times itself, or what we should say is x minus 7 squared, and then square root. You can leave, here's something I didn't say on the last example. If you want, you can leave this as the square root of 33, plus or minus, of course. So leave it as plus or minus the square root of 33, and then go and add 7 to both sides. So x is equal to 7 plus or minus the square root of 33. That'd be a way to express the solution exactly. And then you can just use your calculator and type in x plus the square root of 33 and x minus the square root of 33. And those two solutions are going to come out to 1.26. Again, rounding to the nearest hundredth, and 12.74. Alrighty, thanks for tuning in.